Hello viewers, I'm excited to come your way again in another session in mathematics. Today I'll discuss sequences and series, and of course the objective of the class is to establish what sequences and series is all about. Also look at some mathematical problems that involve sequences and series. Alright, so fasten your seat belts, get a comfortable chair, and let us roll together. Alright, a sequence is actually the arrangement of terms in such a way that the terms are related to one another according to a well-defined rule or pattern. A sequence is the arrangement of numbers that follows a well-defined pattern and order. Alright, now the rules that we can use to arrange this sequence might vary from sequence to sequence. It is not always the same. Alright, so there's a time we have to arrange numbers by having a constant common difference between each two successive terms, and there's also another time we need to arrange numbers by having a constant common ratio between the successive terms. Of course, this gives birth to the types of sequences that we have. We have two types, what we call the arithmetic progression, which is also called the linear sequence, and what we call the geometric progression, which is also called the exponential sequence. Alright, so those are the two types of sequences that we have. You can see on the screen. I've established that a sequence is the arrangement of numbers with a definite rule, with a definite pattern. Alright, we don't just fix numbers without any relationship between the numbers. We find a particular relationship, we establish a relationship, whether it's a constant difference or a constant ratio, and we now begin to place these numbers one after the other. That is what a sequence is. And a series, on the other hand, is actually the summation of the terms of a sequence. So if I have a sequence as 2, 4, 6, 8, 10, that's a sequence. Alright, if I now introduce the addition symbol, 2 plus 4 plus 6 plus 8 plus 10, that becomes a series. So a sequence is the arrangement of numbers with a definite pattern, a definite rule. Alright, whereas a series is the addition of the terms of a sequence. Alright, on your screen you can see that there are basically two types of sequences. We have the first one called the arithmetic progression, and of course we have the second one called the geometric progression. The arithmetic progression, AP, is also called the linear sequence, and of course the geometric progression, GP, is also called the exponential sequence. Alright, so right away we'll discuss what the arithmetic progression is all about in this particular session, and we'll look at a lot of formulas that involve that is used in the arithmetic progression, and also solve a lot of mathematical problems that will take care of that particular point. In the other session I'll be talking extensively about the geometric progression. Alright, so on your screen you can see that an arithmetic progression is a sequence that is characterized by a constant common difference. That is, there is an increase or decrease between two successive terms in the progression, and of course this difference can either be positive or negative. Now this is what we mean. If I have a progression like this, let's say even numbers, so I have 2, 4, 6, 8, 10, 12, and it continues. That's an infinite sequence. It continues. Alright, now if you look at my first term is 2, so this first term is 2, so we have this as T1. Now first term, most of the time we use A to represent the first term. Alright, so my second term here is 4, that's T2. My third term here is 6. My fourth term here is 8. My fifth term here is 10, that's T5. And the sixth term here is 12. Those are the first 6 terms of that sequence. Now, if a particular sequence is to be called a linear sequence or the AP, alright, the AP must always be characterized by a constant common difference. There have to be a difference that is common between each pair of terms successively, and that difference is constant. So we call it common difference D. Now what this means is that D is equals to T2 minus T1. That's the difference between the second term and the first term. So we have T2 minus T1. D can also be given as T3 minus T2. It can also be given as T5 minus T4. it can be given as T10 minus T9. It's always the term in front minus the term behind. Always the term in front minus the term behind. So it can be given as T20 minus T19, T25 minus T24, T50 minus T49. It's always the term in front minus the term behind. So generally, the common difference G is always given as Tn minus Tn minus 1. Anytime you see a sequence that is characterized by a constant common difference, the difference between each successive pair of terms T1, T2, T2, T3, T5, T6, T7, T8, T10, T10 and the next one. Whenever you see a sequence that has a constant common difference between those successive terms, that particular sequence is called the arithmetic progression. It's called a linear sequence. So an example is what you have on the screen: 2, 4, 6, 8, 10, 12. The difference between 2 and 4 is 2 because 4 minus 2 is 2. Difference between 4 and 6 is 2 because 6 minus 4 is 2. Difference between 6 and 8 is 2. 8 minus 6 is 2. Difference between 10 and 12 is 2 because 12 minus 10 is 2. So this particular sequence is called the linear sequence or the arithmetic progression. Alright, so the linear sequence is characterized by a constant common difference. Constant common difference. We call this the linear sequence. Alright, so on your screen, you can see what we call the nth term of an AP. The nth term of the linear sequence. Alright, I've already emphasized the fact that the first term is given as T1 or A. Alright, now in some questions you can be given the first 3 terms, the first 4 terms, or the first 5 terms. And maybe you are asked to find the 20th term, or you are asked to find the 50th term. Now, mathematically, there should be a way where we can find a particular term we are looking for without actually generating them one after the other. Because in mathematics, you want to be efficient. Inside the exam hall, you actually want to be efficient. Alright, so there is need for a formula called the nth term of an AP, where you can use to find a particular term you are looking for at every point in time. Okay, so if for instance now, let's say we have an example on your screen. You have a sequence as, let's say, 1, 4, 7, 10, 13, maybe 16, and it continues. Now this is actually an AP. There is a constant common difference which is 3. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. So the constant common difference here, D, is equals to what? 3. Our first term is what we have there as 1. Now we can be asked to find the, let's say we can be asked to find the 25th term. That's T25. That's T25. We can be asked to find the 25th term. Now if you look at that sequence we have there on the screen, 1, 4, 7, 8, 13 and 16, those are the first 6 terms of that progression, and you are asked to find the 25th term. Now it is not ideal for you to sit down and begin to generate the terms one after the other till you get to the 25th place, or because if you were asked to find the 200th term and you want to sit down to begin to generate that manually, you realize that it's going to be an uninteresting adventure. It's going to be very, very uninteresting. Alright, so there is a need for a formula that can help us find a particular term that will occupy a particular position in that particular progression. That formula is called the nth term of the linear sequence, and is given as Tn, that's for nth term, is equals to A plus into n minus 1d. Because of time and trying to reduce the length of the session so that we will not have too much session, I would have actually proven the formula for us so that we'll see how that was gotten. But at this point, I think how we are going to use it is more important than you trying to establish the proof of it. Alright, so the formula you see there is Tn is equals to A plus into n minus 1d, is the nth term of an AP. This is what we call the nth term of an AP. That's the formula for finding the nth term. So when that n is 25, you are now looking for the 25th term. When that n is 200, that means you are looking for the 200th term. When that n is 50, that means you are looking for the 50th term. on the screen, the sequence I gave has the first 6 terms. So if we were asked to find the 25th term, so we can find that particular term even without knowing what the 7th term is, what the 8th term is, what the 15th term is. That is, you can jump those ones and get to the one you are actually trying to find, which is why this n term formula is very, very important. Alright, so if we are finding T25 now, this is equals to A plus into n minus 1. N now is 25 because that's what we are trying to find. Alright, so we have 25 minus 1 times D. Okay, so the formula for the 25th term is A plus 25 minus 1 is 24 D. Alright, so we can now substitute. That means our T25 is equals to A is our first term, which is 1 plus 24 times D. D is the common difference that I established earlier as T2 minus T1, which is 4 minus 1, giving us 3. So we have 24 times 3. Alright, so if you multiply this, 24 times 3, 3 times this is 12, carry 1, this is 6, 7, that gives us 72. Alright, so that means our 25th term is 1 plus 72. That means our 25th term is actually the number 73. Alright, that is what we mean by the nth term of an AP. Just for emphasis sake, I would love to repeat that again. N term Tn is given as A plus into n minus 1D. This formula is used to find a particular term in the linear sequence. If a question gives you the first 2 terms, the first 3 terms, or the first 5 terms, depending on the examiner, and you are now asked to find a term that is far away, like the next the 50th term or the 100th term, you use this particular formula, the nth term of an AP, which is given as A plus into n minus 1D, to find a particular term you are trying to get. Alright, now sometimes the examiner might not be interested in asking you to find a particular term like the 25th term. The examiner might want to ask you to find the sum of the first 25 terms. It's a different question. Now a sequence can be given as 1, 4, 7, 10, 13 like I wrote earlier, and the question is for you to find the 25th term. Alright, so find the 25th term is T25, which is using the nth term formula. That's Tn equals to A plus into n minus 1D. Alright, that is for finding the 25th term. But if the examiner is interested in you finding the sum of the first 25 terms, that is another formula, which that one is given as Sn formula. This one is used to find the sum. Sum them means from the first term to the 25th term, add them together. That is when you use the Sn formula. T formula is to find a particular term, just one term. Find the 25th term is T25. Let me put it on the screen so that you can understand what I'm saying. Alright, so T25 means you are finding a particular term that occupies the 25th position. Alright, but if you are asked to find S25, S25 means you are finding the sum of the first 25 terms. That's the first term added to the second, to the third, to the fourth, and the rest. That's the difference. Alright, you agree with me that if you were to sit down and generate up to, the first 25 terms of the sequence and now add it one after the other, that's going to be very stressful and again very, very uninteresting. Alright, so there should be a formula that can allow you find this sum of terms even when you don't know the terms. There should be a formula where you can use to solve and find the sum of the first 50 terms even when you don't know each of them. Alright, so we call that the sum of terms formula, and it's given as Sn is equals to n over 2 into 2a plus n minus 1d. Like I said earlier, time will not permit us, because of the brevity of the sessions, for us to actually prove out these formulas we've gotten. But at this point in time, you being able to use it is far more important and imperative than you trying to establish the proof of it. Alright, so the Sn formula is given as n over 2 into 2a plus n minus 1d. Alright, this formula will allow us to find the sum. T formula is to find the particular term, and S formula is to find the sum from the first term to that particular term. Alright, so for Sn formula we have 2. So we can use this when we know the first term and of course we know the common difference, or we can use Sn is equals to n over 2 into a plus l, where l means the last term of that sequence. Some questions will give you that particular point. A question can tell you that find the sum of the first 20 terms of an AP if the first term is 15 and the last term is 400, you know, something like that. All right, so when the question presents you with the last term, okay, you can use the second formula, n over 2 into a plus l. And when the question does not present you with the last term, of course we use n over 2 into 2a plus n minus 1 d, where d is our common difference. All right, so I think we can take an example based on that point, maybe still using that particular sequence that I gave earlier: 1, 4, 7, 10, 13, 16. These are the first 6 terms of an AP. Maybe the question is for us to find the sum of the first 20 terms. Okay, it's for us to find the sum of the first 20 terms. So we're looking for S20, sum of the first 20 terms, S20. All right, so we know that Sn is given as n over 2 into 2a plus n minus 1d plus n minus 1d. All right, so we have S20 as 20 divided by 2, that's n over 2 into 2a. Our a is 1, so we have 2 times 1 plus n minus 1, that's 20 minus 1, 19d, and d of course is our common difference, which is 3. All right, so 20 over 10 over 2 there is 10 into 2 times 1 is 2, plus then we have 19 times 3, that's 19 times 3. 9 times 3 here is 27. Here is 3 plus this is 5, so we have 57. So this is actually 57. All right, so our S20 is equals to 10 into, if you add this up, you have 59, and of course 10 times 59 will give us 590. All right, so that becomes the sum of the first 20 terms of the AP, which is different from finding the 20th term. Finding the 20th term, of course, will demand that you use Tn formula, which is T20 now, and finding the sum of the first 20 terms is for us to add from the first term to the 20th term, even when we don't know the terms. That is why we are using the formula to just add it up together. All right, so those are the formulas that are applicable in the arithmetic progression. So in a nutshell, I have established what the AP is all about as a sequence that is characterized by a constant common difference, and also I have established what is called the nth term of an AP, which is actually Tn is equals to a plus into n minus 1d, and of course I've also established what the sum of terms in a linear sequence is all about. All right, having established what the linear sequence is, at this point in time it's very imperative that we look at the questions we have and try to solve some mathematical exercises that involve the linear sequence. All right, so on your screen you can see a list of questions. We'll start with question number 1. Now question number 1 says that if 8, x, y, z, 20 are the first 5 terms of an AP, we are asked to find the values of x, y, and z. 8, x, y, z, 20 are the first 5 terms of a linear sequence. We are asked to find the values for x, y, and z respectively. Alright, so from what we have established so far, that a linear sequence is a type of sequence that is characterized by a constant common difference. And of course, this common difference can either be positive or can be negative. Alright, so at this point we are told that 8, x, y, z, 20 forms an AP. Alright, so if you look at this, these are the first 5 terms of the sequence, where our a, which is the first term, is 8, y there means, okay, x there means the second term, y is the third term, z is the fourth term, and of course 20 is the fifth term. Alright, so we can say something like T5 is equals to 20 from this question we have on the screen. Alright, now earlier I have told you that the nth term of a linear sequence is given as a plus into n minus 1d. Alright, this is the formula we can use to find the particular term in a given linear sequence. Alright, so if we are talking about this T5 that is 20, if we interpret it using this formula now, we can have that T5 is equals to a plus into n minus 1. N there is 5, so 5 minus 1 is 4. So we have a plus 4d, giving us, that's a plus 4d, giving us the expression for the fifth term, a plus 4d. A plus 5 minus 1 is 4 times d is d. Alright, so this t5 that was equals to 20 can be written as a plus 4d is equals to 20. By the formula, that's Tn formula, t5 means a plus 4d, so we equate it to the 20. Alright, here this is a simple linear equation where we can make d the subject, given that we know a as the first term as 8 from the equation. So from our equation, the first term is 8, so we have that 8 replaces a plus 4d is equals to 20, which will give us, that's 8 plus 4d is equals to 20. We take 8 to this other side, we have 20 minus 8. So here will give us 4d is equals to 20 minus 8 will give us 12. Alright, so d is for us to divide both sides by 4. That's if we are trying to make d the subject of formula. So we have 20 divided by 4. And of course, g here will give us this number called 3. Alright, so 3 is our common difference. 3 is the common difference. 8 is our first term. We were asked to find the values for x, y, and z, given that 8, x, y, z, 20 will give us an AP. Alright, so our AP was actually given as 8, x, y, z, and 20. Our first term has been established as 8, which is, of course, that's the first term in the progression. Our difference now has been established as 3. So find the value of x means x is t2. You know this 8 here is the first term, which is a. This x here means t2, y here means t3, and z here means t4. Alright, so x is equals to t2, which by formula, the Tn formula says that a plus n minus 1d will always give us the value for a particular term. Alright, so x is our second term, which by formula we have a plus n minus 1 is now 2 minus 1. So that will give us 2 minus 1 is 1 times d is d. So we have a plus d as the mathematical formula for finding the second term, a plus d. Alright, so this is equals to our a is 8 plus our d is 3. So 8 plus 3 will give us 11. So 11 is the value for x, which automatically means our second term. Alright, the value for y means the third term. That's the third term now, which is equals to, from the Tn formula we have a plus into n minus 1. So we have a plus n minus 1 is 3 minus 1, which is 2. 2 times d is 2d. So a plus 2d is the formula for finding the third term in a given linear sequence. Alright, so this is equals to a is 8 plus 2 times d, 2 times 3. So this is going to give us 8 plus 6, which of course is equals to 14. So our third term, which is the value for y, is of course equals to 14. And finally, the next guy is z, which is t4 in the progression. Z means the fourth term. So from the formula we also have a plus into n minus 1. 4 minus 1 will give us 3. So we have a plus 3 minus 4 minus 1 is 3. So we have 3 times d is 3d. So a plus 3d is the mathematical expression for finding the fourth term of a linear sequence. So we have a plus 3d. We now substitute. A here is 8, which is our first term, plus 3 times d is also 3. Alright, so this will give us 8 plus 9, which of course is equals to 17. So the progression that was actually 8x, y, z, and 20 can now be expressed as 8, x is 11, y is 14, this is 17, and of course we have 20. That was actually our linear sequence. So that's how we can use the knowledge of what I established earlier in this session, talking about the linear sequence, to be able to find the values of x, y, and z. So the x, y, and z were actually used to represent the second term, the third term, and of course the fourth term of the linear sequence respectively. Alright, I'm sure that I've established a good explanation with respect to that particular mathematical exercise. Alright, so we go back to our question list, and of course we try to pick another example and see how we can play with it. Alright, now for our question number 2, we are asked to find the 6th term and also the 15th term of the AP. whose first term is 6 and the common difference is 7. I'll leave you to this because I'm sure it's something you can attempt. We're asked to find the 6th term. Using the Tn formula, we're going to have a plus 6 minus 1 is 5. So we have a plus 5d. Of course, a has been given as 6, which is the first term. D has been given as 7. So you just replace it and you get your answer. Alright, we're also asked to find the 15th term. Using the Tn formula, you also have a plus 15 minus 1 will give you 14d. So a plus 14d is the mathematical formula for finding the 15th term, where a of course is 6 according to the question, and 7 is the common difference. You fix it up, of course you have the answer. And of course the third exercise is exactly the same as the first one I just solved. A, B, C, D are used to represent the second, the third, the fourth, and the fifth term of the progression respectively. Where 38 of course is the 6th term. So you say a plus 5d as the formula for the 6th term is equals to 38. You substitute the first term as 8, you'll be able to make d the subject, which is the common difference, and of course you can tidy it up from there. Of course, I would love to see whatsoever you have as the answer in the comment section of the video. So lay your hands on the second question and also the third exercise. I would love to review your answers in the comment section. Alright, now if you look at the fourth question now, we are asked to find the value for x given that x plus 1, 2x and 2x plus 3 are the consecutive terms of an AP. We are asked to find the value for x if x plus 1, 2x, 2x plus 3 are the terms consecutively in an AP. Alright, so what we have there is actually x plus 1. Our first term there is x plus 1, second term is x plus 2, and third term is 2x plus 3. So we have x plus 1 in bracket, 2x and also 2x plus 3 are the first three terms, because the question said consecutively, so that means they are the first three terms of a linear sequence. So that means x plus 1 is actually t1, which is also called a. 2x is actually t2, our second term, and 2x plus 3 is actually our third term. Now what I pointed out earlier when we started this session was that a linear sequence is characterized by a constant common difference. That difference is the same in the whole progression, and that difference is given as d is equals to t2 minus t1. It should be the same thing as d is equals to t3 minus t2. Even if you have up to 10 terms in the progression, that means d can also be written as t10 minus t9, t11 minus t10, always the term in front minus the term behind. So we have it generally as tn is equals to, d, we have it generally as d, that is the difference, to be equals to tn minus 1. So if n is 10, so the next guy is n minus 1, 10 minus 1, which will give you 9. So t10 minus t9 is our common difference. Alright, for this question we have just 3 terms. So we can write our first common difference as d1, which is t2 minus t1. So this is going to give us t2 is 2x minus t1 is x plus 1. If you notice, I put that in the brackets because you know that term is a binomial term, x plus 1. The negative sign is going to open that bracket. Alright, so this is going to give us 2x minus x, then minus 1. That's the negative sign opens the bracket, you have minus x minus 1. Alright, so this is equals to 2x minus x is x, then minus 1 is left. That is the value for our first common difference, which is t2 minus t1 with respect to that question. Also, another difference can be established as t2, which can be written as t3 minus t2. The first common difference there is t2 minus t1, which will give us the common difference in terms of x. And also the second one is t3 minus t2, which will also give us the common difference in terms of x. Alright, so we also have t3 minus t2 now. Our t3 is actually 2x plus 3 minus our t2 is actually 2x. Our t2 is 2x. Alright, so we have that our d2 common difference is equals to 2x plus 3 minus 2x. So 2x minus 2x will go. So what we have left here, d2 is actually equals to what? 3. D2 is actually equals to what? 3. Alright. So at the end of the day, you know that the common difference is always constant in a particular progression. If it is the AP, which is the linear sequence, the common difference is always the same. Even if you find 10 of them, they are always the same. Alright, so D1 is equals to D2, they are always the same. So we are going to equate that. Our D1 gave us x minus 1, and D2 is giving us the value which is 3. So D1 should always be equals to D2. So we have D1 is equals to D2. The question asks us to find the value of x. So we equate them now. Alright, so D1 is x plus 1, and this is equals to what? 3. I think we had x plus 1. Oh, sorry, x minus 1 rather. We had x minus 1 as the value for D1. Okay, so this place is x minus 1, not plus. Okay, we have x minus 1 here. Okay, so we have x minus 1, of course, is equals to 3. So the value of x now is equals to 3 plus 1. So x is equals to 4. So that's how we can find the value of x, given that x plus 1, 2x, 2x plus 3 are the consecutive terms of an AP. Alright. Okay, straight away we go back to our question list and we look at question number 5. We are told that the fourth term of an AP is 15, and of course the ninth term is 35. We are asked to find the 15th term. The fourth term of an AP is 15 and the ninth term is 35. We are asked to find the value of the 15th term. Okay, so we solve that. Our fourth term of an AP is 15. So T4 of an AP is 15, and the ninth term is equals to 35. We are asked to use these two pair of information to find the value of the 15th term, that's T15. Alright, now the nth term of the linear sequence, which I have established in this session, is a plus into n minus 1d. That is the nth term. So if we were told that the fourth term is 15, so mathematically using the formula, our fourth term T4 would have been a plus 4 minus 1 is 3. So we have a plus 3d. A plus 3d is the mathematical formula for finding the fourth term. And of course, this is equals to what? 15. We call this equation 1. And the ninth term was given as 35. So we have that T9 is equals to a plus, formula for ninth term will be a plus 8d. That's 9 minus 1. A plus into n minus 1d. Okay, so we have a plus 9 minus 1 is 8, so we have 8d, and this is equals to 35. We call this equation 2. So we can solve this pair of simultaneous equations. Okay, equation 1 and 2. Okay, so we can quickly say equation 2 minus equation 1 using elimination method to solve that. So a minus a is gone. 8d minus 3d will give us 5d. So we have 5d is equals to 35 minus 15, of course, will give us 20. So this is equals to 20. So at this point, if we make d the subject, we have 20 divided by 5, making d to be equals to 4. So we've gotten d as 4. Alright, since we're solving a pair of simultaneous equations here with two unknowns, a and d, now we've gotten d as 4. We need to replace it into either equation 1 or equation 2 to be able to find the value for the other unknown, which is a. Alright, so we substitute d equals to 4 into equation 1 to be able to find a. Now equation 1 was that a plus 3d is equals to 15. So if d is now 4, we have a plus 3 times 4 is equals to 15. So we have a plus 12 is equals to 15. So a, which is our first term, is 15 minus 12. You know, plus 12 crosses equality sign and becomes negative 12. Alright, so a is equals to 15 minus 12, of course, will give us 3. So that's the value for the first term. Our first term is 3 and our common difference is 4, which is d. We were asked to find the 15th term. Okay, so the 15th term is actually by formula also. Tn formula is a plus into n minus 1d. So T15 is actually a plus 15 minus 1 will give us 14. So we have 14d. That's the formula for finding the 15th term. And we know a to give us 3 from what we solved earlier, and we know D to give us 4. So we replace 3 and 4 for A and D respectively. So that means our T15 is equals to A is 3 plus 4 times 4. So we have 3 plus 4 times 4 is 16. So this is equals to 19. That means that the 15th term of that linear sequence is 19. Given that the 5th term was 15 and of course the 9th term was 35. Alright, that has been our explanation as far as the linear sequence is concerned, where I was trying to look at some mathematical problems that involves the linear sequence. In our next session now, our next video, we'll be looking at the geometric progression, which of course is the second type of sequence that we have. Thank you.